In this video, we're going to solve these system equations. The first one, xy plus x plus y equals 71. The second one, x squared y plus xy squared equals 880. Here x and y are positive integers. Then we want to solve for x and y. This question is from AIME. We're going to consider two cases. The first one, x less than or equal to y. Because we notice the two equations, they are symmetrical in x and y. So that's why once we got an answer for x less than or equal to y, then we can easily get the answer for the second case, y less than x. So now let's get started from the first equation. So first equation, xy plus x plus y equals 71. Then we want to put the left-hand side as a product. So then here we put this is the first factor, then this is the second factor. Because here we have xy, so we put the x here, then we put the y here. So here we have x, then here we'll put a plus 1. Here we have y, so then here we plus 1. Then we have one extra term, 1 times 1. Then outside we minus 1. Then equals 71. Then we have here x plus 1, then y plus 1, then equals 72. Now let's prime factorize 72. That's 8 times 9, so that's a 2 to the third, then times 3 squared. Okay, so now let's see. Because x and y are positive integers, so that means x plus 1 and y plus 1 both must be bigger than or equal to 2. Because here we consider the first case x less than or equal to y. Here consider x less than or equal to y. Then here we have then both sides plus 1. Then we have x plus 1 less than or equal to y plus 1. So now we can consider how many possible sets for x plus 1, y plus 1. So then here, x plus 1, y plus 1, based on the prime factorization and satisfy the two conditions. Okay, so let's see the first one. X plus 1, because it must be bigger than 2, so we're going to start from 2. Okay, equals 2. Then what's the second number? The two numbers multiplied together equals 72. So that's why here, that's 36. Now let's see the second case. X plus 1 equals 3. Then here, 3. Then this number, that's 24. Again, the two numbers multiplied together equals 72. That's the second case. Let's see the third case. Third case, that's 2 squared, that's 4. Then this one, 18. The next one, 2 times 3, that's 6. Then here, 12. Next one, 2 to the third, that's 8. Then 9. Then we just stop here. Why? Because next one will be 9. Next one will be 9, 8. It won't satisfy this condition. Because here must be x plus 1 less than or equal to y plus 1. So that's why we just stop here. So next, let's figure out what is xy. Just all the numbers minus 1. Then here just 1, 35. Then here 2, 23. Then here 3, 17. Then here 5, 11. Then the last one, 7, 8. Okay, so then here that's the possible sets for x and y. So now let's look at the second equation. The second equation, that's x squared y plus xy squared equals 880. Now let's take out the common factor. So that's xy, then the inside x plus y, then equals 880. So now let's prime factorize 880. Because that's 8 times 10 times 11, so then here just 2 to the 4th times 5 times 11. So now let's look at here. So the left hand side we have 3 factors. Then the right hand side we have 11 as a prime factor here. So then we want to figure out for these 3 factors which one is divisible by 11. Okay, so now let's see. So let's see the first one. Let's see x plus y. So here, x plus y, just 2 numbers adding together. So 1 plus 35, 36, this is 25, this is 20. So then here we have the x plus y is 36, 25, 20, 16, 15. Then from here we can tell by looking at all the numbers, so then x plus y is not divisible by 11. So then we have, then x plus y is not divisible by 11. That's the first case. So now let's see x. So now let's see x. X here, just 1, 2, 3, 5, 7. So now let's see here. So then we have x here just equals 1, 2, 3, 5, 7. And also we can tell easily that x is not divisible by 11. Then what that means, so that means x and x plus y are not divisible by 11. That means y must be divisible by 11. So that's why here we have, then we have just y is divisible by 11. So then we have this conclusion. So now let's look at the 5 possible sets. Okay, look at the 5 possible sets here. So then this is the only one has 11 as a factor. So that's why, so this is a solution for x, y. So 5, 11. So that's why we got this conclusion. So x, y equals 5, 11. Then by checking, so 5, 11 is a solution of the system equations. Okay, so that's for the first case. Now let's see the second case. Second case, that's y less than x. Because the 2 equations are symmetric above x and y. So that's why, so what is the solution for this case? So then solution for the equation 1 y less than x, simply flip the 2 numbers. So that's 11, 5. So then combine the 2 cases. Then we have the solution of the equation. Then x, y equals 5, 11, or 11, 5. So they are the 2 solutions of the system equations.